Morning. Today we are going to discuss about DevOps. What is DevOps? What are the different stages of DevOps lifecycle and 7 C's of DevOps? First, let me explain about what is DevOps. DevOps is a modern approach to the software development that brings development and operations teams together to deliver applications faster and more reliable. It focuses on collaboration, automation, and continuous improvement across the software lifecycle. DevOps encourages close collaboration between development and operations teams. DevOps automates build, test, and deployment processes to reduce errors. DevOps enables faster and more frequent software releases. DevOps improves system reliability, monitoring, and feedback loops. DevOps lifecycle. The DevOps lifecycle is a continuous looping process that bridges the gap between software development and IT operations. Unlike traditional models where development and operations were independent steps, DevOps integrates them into a single infinite loop of collaboration, automation, and feedback. The DevOps lifecycle is a set of continuous and collaborative practices that bridge the gap between software development and IT operations, promoting seamless integration, automation, and faster delivery of software. Figure shows the sequence of different phases of DevOps lifecycle. They are plan, code, build, test, deploy, operate, feedback, and monitor. Let me explain these stages one by one. The first stage is planning. Plan. As the name suggests, this stage involves planning the entire project lifecycle. During this stage, the essential stakeholders, product managers, project managers, developers, and operations team hold meetings to discuss the project requirements and performs necessary analysis to come up with a strategic approach to build the application. During this stage, details on resource allocation, project timeline, team structures, tech stack, tools, and risk mitigation approaches are also decided. The next stage is code. Before the coding stage, there can be a preliminary design stage where software engineers analyze and identify the best solutions to create the software. For example, they can decide on an appropriate architectural pattern that best fits the project's needs, then break down the system architecture into smaller, more manageable components. At this point, developers start to work on the code. Version control systems like Git are used to manage code changes and enables collaboration among team members. The next stage is build. With the new code is ready, it is now time for developers to integrate code changes into a shared repository, ideally multiple times a day. Continuous integration plays a crucial role here, which ensures that any integration issues are detected and resolved early on so that the code base is always in a consistent and working state. Once the developers commit code and the lead developer approves, the continuous integration process is triggered, initiating the build process. The continuous integration server will compile the source code into low-level machine code that can be executed. Continuous integration tools also identify the dependencies such as external libraries, frameworks, and modules required for the code to run properly. The output of this build process is a build artifact, an executable and deployable form ready for testing and distribution to the end users. The fourth stage is test. This is a critical phase to ensure the software's quality and reliability. A wide variety of tests are performed to validate all aspects of the build, including functionality, performance, aesthetics, security, and more. Automated testing is key to DevOps as it enables faster and more reliable verification of code changes, reduces manual effort, and facilitates continuous integration and continuous delivery. Testers need to perform automated testing at all levels, including unit, integration, and system testing. Unit testing is to verify the functionality of individual units of the code. Integration testing is used to verify the flow of data between different code units or components, ensuring that they communicate effectively with each other. System testing is used to test user interaction in an environment as closely related to the production environment as possible. The next phase is deploy. During this phase, the code that has been thoroughly tested is released and deployed to different environments, including staging environment, UAT environment, and production environment. The software application is now available for users to access and interact with, but the level of access differs for each. In the staging environment, also known as a pre production environment, is a near exact replica of a product environment for software testing. These environments bridge the development environment with production environment, providing a preview of how the software works and ensuring it aligns with stakeholders' expectations. In the UAT environment, where the code is deployed after software testing is completed on staging, it is also a near exact replica of the production environment, but customers or product owners perform testing here instead of QAting. Production environment is where the final deployment is done, also called live environment. All customers can interact with it in real time. During this stage, bugs are not expected to be found. If a bug is found, the QA will immediately be alerted. Automated deployments are extremely valuable to create a seamless flow, simplifying the deployment process and reducing human errors. It is also the key to achieve continuous deployment where software changes are automatically pushed to production environments as soon as they pass automated tests. The next stage is operate. Once the software is deployed, it enters the operational phase where it is fully available for use by end users. A dedicated operations team will take over the management of the software in the production environment, performing many tasks to keep it running smoothly, ensure its availability, and make optimization decisions to bring better experience to the users. Next stage is feedback. The feedback stage in DevOps is the continuous process of gathering, analyzing, and acting upon data from production, operations, and users to improve software quality and development speed. It bridges development and IT operations, acting as a critical loop that drives iterative enhancements, fixes bugs, and informs future planning, ensuring the development cycle adapts continuously. The next stage is monitor. The monitor stage in the DevOps lifecycle is a continuous process of collecting data from production to evaluate application performance, infrastructure health, and user experience. It uses real time metrics, logs, and alerts to identify issues early, ensure stability, and provide critical feedback to improve future deployment cycles. 7 C's of DevOps. The 7 C's of DevOps are core principles that help make DevOps successful. They guide how teams work together, build, test, and deliver software faster and more reliable. Each of these C's contributes to a workflow that enhances the quality, speed, and reliability of delivering software products. They are continuous development, continuous integration, continuous testing, continuous development or continuous delivery, continuous monitoring, continuous feedback, continuous operations. Let me explain these 7 C's one by one. The first one is continuous development. Continuous development involves the iterative and incremental approach to the software creation where development teams plan, code, and prepare software features in small manageable units. This methodology enables rapid feedback, early detection of issues, and swift delivery of value to end users. It integrates closely with version control systems and automation tools to streamline development process. For example, imagine a team building a food delivery app. Instead of waiting to finish the whole app and testing it later, the team adds features one by one. For example, on Monday, the team add a login feature and test it immediately. On Tuesday, the team adds a search for restaurants feature and tests that too. Each feature is checked and added to the live application as soon as it is ready. This way, if there is a problem in the login part, they can fix it right away without affecting other parts. Next one is continuous integration. Continuous integration in DevOps ensures that code changes made by developers are automatically built, tested, and integrated into the main code base. This process typically involves four key stages. The first stage is source code management. Developers push their code from local machines to a remote repository such as GitHub. This allows teams to collaborate, review, and manage code versions easily. The second one is build process. The source code is then compiled using tools like Maven, which packages the application into artifacts such as jar, var, or year files. Third one is code quality check. Tools like SonarQube analyze the code for bugs, code smells, and security issues. It generates detailed reports to maintain code quality standards. Fourth one is artifact repository. The generated build artifacts are stored in a repository manager like Nexus, which serves as central storage for future deployment. All these steps are automated using Jenkins, a popular continuous integration tool that orchestrates the complete flow from fetching code to sorting the final build artifact. For example, let us say your team adds a new feature track delivery person on map. Developer Meena writes code for the tracking feature and pushes it to GitHub. As soon as the code is pushed, Jenkins picks it up and uses Maven to build the application and test it using JUnit. The code goes through SonarQube, which finds a few duplicate lines and suggests better practices. Once everything is okay, the final app version is saved in Nexus as jar file. This way, every small change is tested, verified, saved automatically without manual effort. Next one is continuous testing. Continuous testing means testing the code automatically every time there is a change. This helps catch bugs early before app goes live. With DevOps and Agile methods, companies can use tools like Selenium, Test Sigma, or Lambda Test to test their applications automatically. These tools run tests faster and smarter than manual testing. Using a tool like Jenkins, we can set up the entire testing process to run automatically after every code change. This saves time and reduces human errors. For example, let us say your team adds a new feature, apply coupon at checkout. After the developer pushes this new feature to GitHub, Jenkins automatically starts the testing process. Tools like Selenium or Test Sigma test: does coupon code apply correctly? Does final price updated as expected? Does checkout process still work? If a problem is found, for example, the application crashes when a wrong coupon is entered, the test will fail and the developer will be noticed immediately to fix it. This way, the team avoids pushing broken features to production and ensures the application remain reliable. Next one is continuous development or continuous delivery. Continuous development. Continuous development is the process of automatically deploying an application into the production environment when it has completed testing and the building stages. Here we will automate everything from obtaining the application's source code to deploying it. Continuous delivery. Continuous delivery is the process of deploying an application into production servers manually when it has completed testing and building stages. Here we automate continuous integration process. However, manual involvement is still required for deploying it to the production environment. For example, suppose the team adds a refer and earn feature. The code is developed, tested, and marked as ready to go live. However, the product team decides to launch it during a weekend campaign. Until then, the feature stays on standby in the staging area. Once approved, the code is manually deployed to production using a single click. So, continuous delivery ensures every update is deployable anytime, but the actual release can be controlled. Next C is continuous monitoring. Continuous monitoring in DevOps is the real-time automated observation of applications and infrastructure throughout the entire CI/CD pipeline. It detects errors, security vulnerabilities, and performance bottlenecks early, reducing downtime and enhancing user experience by providing actionable data from development to production, often using tools like Prometheus, Grafana, and ELK. For example, let us say your application suddenly takes longer to load the order history page. Prometheus tracks this slow response time and sends an alert to the team. Grafana shows a graph that spikes during dinner hours when traffic is high. The team uses this data to adjust the server settings or optimize the code. This prevents crashes and keeps the application smooth for all users, especially during peak hours like dinner time. Next C is continuous feedback. Continuous feedback in DevOps is the automated real-time loop of information covering code quality, system performance, and user experience that enables teams to detect defects early, improve code quality, and accelerate development cycles. It transforms DevOps into a self-improving system by providing actionable data to developers, testers, and operations teams to iterate quickly. Next is continuous operations. Continuous operations in DevOps is a practice designed to eliminate or drastically reduce scheduled downtime during software updates and maintenance. It ensures 24 by 7 system availability by using automation, small frequent releases, and robust monitoring to maintain service continuity while enabling seamless deployment of new features and fixes.